Welcome to this lecture on microwave ovens and dishwashers, two important electronic appliances commonly used in modern homes. Let us begin with microwave oven. A microwave oven works on the principle of converting electromagnetic energy into thermal energy. Unlike conventional cooking methods, where heat is transferred from the outside surface toward the inside of the food, microwave cooking directly heats the food from within. Microwave radiation penetrates the food and interacts primarily with water molecules present inside it. This process enables faster and more efficient cooking. One major advantage of microwave cooking is nutrient preservation. Since cooking time is shorter and heating is more uniform, a higher percentage of vitamins and nutrients can be retained compared to traditional cooking methods. Due to their speed, convenience, and energy efficiency, microwave ovens have become an essential appliance in homes, restaurants, office, and food service industries. This diagram illustrates the internal structure of a microwave oven. The major sections include the magnetron, high voltage power supply, waveguide, cooking cavity, cooling fan, and the electronic control unit. The magnetron is responsible for generating microwave energy. The waveguide directs this energy into the cooking chamber where it is absorbed by the food. The rotating turntable ensures uniform exposure of food to microwave energy, resulting in even heating. Safety features such as interlock switches prevent operation when the door is open, protecting users from microwave exposure. So together, these components ensure safety and efficient cooking performance. Let us now understand the major components of a microwave oven. The first component is the high voltage transformer. It converts the normal supply voltage into a much higher voltage required by magnetron. The second component is the cavity magnetron. This is the most important part of the microwave oven because it generates microwave radiation. The third component is the microcontroller. It acts as the brain of the system and controls cooking time, power levels, temperature settings, and various operating modes. The fourth component is the waveguide. It channels microwave energy safely from the magnetron into the cooking chamber. The fifth component is the cooling fan. It removes excess heat generated during operation and prevents overheating of internal components. Each of these components play a vital role in maintaining efficient and safe operation. Now let us discuss the working mechanism of a microwave oven. When the oven is switched on, the magnetron generates microwave radiation. These microwaves enter the cooking chamber through the waveguide. The microwaves penetrate the food and interact with polar molecules, especially water molecules. Because water molecules have opposite, that is positive and negative ends, they continuously attempt to align themselves with the rapidly changing electric field of the microwave waves. This realignment occurs millions of times every second, causing intense molecular movement and friction. The friction generates heat within the food itself. This phenomenon is called dielectric heating. As the amount of molecular motion increases, the temperature of the food rises, resulting in cooking or heating. This mechanism allows microwave ovens to heat food much faster than the conventional ovens. Let us now move on to the dishwashers. A dishwasher is an automated appliance designed to clean dirty dishes with minimal human effort. The user simply loads the dishes into tracks or racks, adds detergent, selects an appropriate washing program, and starts the machine. After that, dishwasher automatically performs all cleaning operations including washing, rinsing, drying. Because of their convenience and water-saving capability, dishwashers are becoming increasingly popular in modern homes and commercial kitchens. Dishwasher construction. This figure shows the internal arrangement of a dishwasher. Inside the dishwasher, dishes are arranged in upper and lower racks. Spray arms are positioned strategically to distribute water uniformly throughout the chamber. The appliance also contains filters, pumps, heating elements, sensors, and control circuits. The electronic controller coordinates all these components to perform washing cycles efficiently. The design ensures that water reaches all dishes for efficient cleaning. This illustration provides another view of the dishwasher construction and working arrangement. Important components include the water inlet valve, circulation pump, spray arms, heating elements, drainage system, detergent dispenser, and sensor units. The coordinated operation of these components ensures thorough cleaning while minimizing water and energy consumption. So advanced dishwasher systems also include smart sensors that optimize washing performance according to the dirt level and load size. Let us study the dishwasher operation step by step. First, cold water enters the dishwasher from the household water supply. Next, the heating element located at the bottom raises the water temperature to an appropriate level of the cleaning. An electric pump then circulates the heated water throughout the machine. The water is forced through rotating spray arms that contain multiple nozzles. As the spray arms rotate, powerful jets of water strike the dishes from different angles, removing food particles, grease, and stains. After hitting the dishes, the water collects at the bottom of the machine. The collected water is filtered, reheated if necessary, and recirculated through the system. This continuous circulation process ensures thorough cleaning of all utensils. In the final stage of operation, several sensors monitor temperature and water levels. These sensors prevent overheating, monitor water conditions, protect the dishwasher from overflow situations. Once the washing and rinsing cycles are completed, the wastewater is drained from the machine through the drain pump. Many dishwashers then initiate a drying cycle. During drying, the heating element warms the air inside the chamber, helping moisture evaporate from dishes and utensils. At the end of the cycle, the dishes emerge clean, sanitized, and dry, ready for use. This fully automated operation significantly reduces the manual effort while providing consistent and hygienic cleaning results. So in this lecture, we have studied the construction, components, and working principle of microwave ovens and dishwashers. We learned how microwave energy cooks food through a dielectric heating and how dishwashers automate the cleaning process using heated water, pumps, spray, arms, and sensors. In the next lecture, we will discuss induction stoves, uninterruptible power supply systems, commonly known as UPS. Thank you for watching.